Good day. I am Dr. Ismail C., retired professor, Government Engineering Colleges. In today's presentation, I'll be discussing how to use Matlab for the computation of single-phase transmission line inductance. Okay, we can directly move to the session. So the question is, a 20-kilometer long single-phase transmission line has two parallel conductors separated by 1.5 meters. The diameter of each conductor is given as 0.823 centimeter. The conductor has a resistance of 0.311 ohm per kilometer. Calculate the total loop impedance of the line at a frequency of 50 Hz. This is the question. So, how to solve this question? Before coming to the calculation side, we will understand what is the problem. This is the problem given. There is a transmission line. Let us consider it as the line A, and the return line we can consider it as line B. The total length of the transmission line is given. It is 20 kilometer. The diameter of each conductor, that is same, that is also given, that is 0.823 centimeter. From this, the question asked is to find the impedance of the line. So what are the given parameters? Resistance per kilometer per conductor is given as 0.311. The diameter of the conductor is given, D is equal to 0.823. From the diameter, we can calculate the radius of the conductor, D by 2, which is equal to 0.0823 by 2 is equal to 0.4115 centimeter. So we need every dimension in meter. So we are converting into meter, we will be getting 4.115 into 10 raised to -3 meter. The separation between, the distance between the conductor is also given, it is 1.5 meter. So we will solve the problem first. So the given resistance per kilometer per conductor is 0.311. And we know that the total length of the transmission line is 20 kilometer. And there are two conductors. So the total resistance value is given by 2 into 20 kilometer into 0.311 ohm per kilometer. By computing using calculator or Matlab, we will get the answer as 12.44 ohm as the resistance of the entire conductor. Now we will calculate inductance and reactance of the conductor. First, we will calculate the inductance per loop or two parallel conductors over 20 kilometer loop. For that, we need a radius of the conductor and the distance between the conductor. So the inductance formula is L is equal to mu naught divided by 2 pi ln d by r dash, where r dash is usually called geometric mean radius of the conductor. If you substitute the value of mu naught is equal to 4 pi into 10 raised to minus 7, you will get L is equal to 2 into 10 raised to minus 7 ln d by r dash Henry per meter. So moving to the calculation, the formula L is equal to 2 into 10 raised to minus 7 into L into d by r dash is for a single line. So first we will calculate for the single line. So substitute the value of d and r dash. So r dash means geometrical mean radius. To calculate that, you have to multiply the original physical radius of the conductor by 0.7788. So we'll be getting 0.0032 meter. So substituting that value here, we already substituted d is equal to 1.5. Then the value is 0.0032. Now, if you plug these values into in a calculator, we will get 1.23 into 10 raised to minus 6 Henry per meter. So this is for the inductance per meter. So we have to calculate for inductance for two conductors and a total length of per conductor is 20 kilometer. Hence, we have to multiply this inductance value by first into 2, then into one side length of the conductor. So by calculation, we will get 0.04918 Henry is the total inductance of the transmission line. Usually this is also called loop inductance of the transmission line. Now from this inductance, we can calculate inductive reactance by using the formula XL is equal to 2 pi FL total. The frequency is also given to us. So substituting that values 2 pi into 50 into the value of inductance is 0.04918. We'll be getting XL is equal to 15.45 ohm for the total transmission line. Finally, we can calculate the loop impedance using the formula Z is equal to square root of R square plus XL square. So just substitute the value of total resistance obtained from the previous slide. R total is equal to 12.44 we got. Then substitute the value of XL 15.45. By calculation, we'll be getting Z is equal to 19.835 ohm. The problem is taken from Power Systems by V.K. Mehta. It's a tutorial problem. The problem is not solved in the textbook, but the answer is given. 19.86. Our answer is almost matching with that given answer. Now, I will explain how to do the same problem using a Matlab program. So, for writing a Matlab program, first you can write what are the given quantities. So, the resistance of the transmission line is given ohm per kilometer. So I am using a variable resistance per kilometer. Resistance underscore per underscore kilometer. That is equal to 0.311. So that I am assigning 0.311 to the variable resistance per kilometer. Now I am using n conductors is equal to, so totally we have two conductors, it's a single phase line. So I am storing the 2 to a variable n underscore conductors. Similarly, the total length of the conductor I am assigning the 20 kilometer to another variable line length kilometer, line underscore length kilometer. Now spacing between the conductors that I am assigning to a variable d, and a conductor diameter in centimeter I am assigning d underscore centimeter. Then frequency of the system is assigned it to variable f. So these are the first step for writing a MATLAB program. No need to use the same variable. You can use your own variables in your program. Now moving to this is the calculation part. For the calculation part, we have to find out the radius from the diameter of the conductor. For that, we have to first divide it by 2. Then the diameter is in centimeter. So I am converting into meter by multiplying 10 into 10 raised to minus 2. So this is the step. Now I am calculating what is the loop resistance of the conductor by simply multiplying resistance per kilometer into line length into kilometer into n conductors. So by this step, I can get the total loop resistance. So resistance per kilometer that I have already assigned a variable. So then line length kilometer that also we assigned. Then n conductors that also assigned. I think you are remembering it in the previous slide. See, these variables we already assigned. Resistance per kilometer, n conductors, line length. So just multiplying these 3 quantities, you will be getting loop resistance. Now, after that, I am calculating, I am doing the inductance part. For that, first I am calculating what is GMR. The expression for GMR, geometric mean radius, is 0.778 into R. So, inductance of a single conductor per meter is given by the formula 2 into 10 raised to minus 7 into log D by GMR. So, we already defined what is G and we calculated GMR here. So by the MATLAB will calculate what is the inductance of a single line. Now for finding the total inductance or the loop inductance, we have to multiply that single line into 2 as well as it is for total length of the line in kilometer and that kilometer is converting into meter. That is why this 10 raised to 3. That is 10 raised to 3 is represented as in MATLAB is 1E3. Okay. So from this we'll be getting the total inductance of the transmission line. From that we can find out what is the inductive reactance using the formula XL is equal to 2 pi FL loop. So XL is equal to 2 into pi into F into L loop. L loop you already calculated from here. From that, you can calculate the loop impedance magnitude using the formula Z is equal to square root of R loop square plus XL square. Then if you need, you can find out the phase angle of the impedance using tan inverse. That tan inverse is represented as A tan 2. That's a function to calculate tan inverse in MATLAB. And we need the answer in degrees. That is why I am multiplying with the 180 by pi. So we'll see the results. That is, if you want to print the results, you use fprintf, that is similar to your C program. Loop resistance, this is the number of decimal places required. Then R loop, you already calculated what is R loop. Similarly, you already calculated what is L loop. Then that is what are the things to print. It is clear from here. Now, after running the program, I'll be getting like this. I'll show you the demonstration. So this is my MATLAB window. I have MATLAB window. I have typed the program in an editor, MATLAB editor. So you can see the same program here, what I typed. Now, after typing it, you can save it. You can save it with some file name. Then now you can run the program. After running, you'll be getting the answer. So this is about how to calculate inductance of a single phase transmission line using MATLAB. The second part of this video, I'll be solving another problem. Thank you for watching.